This video will take you through all the things you need to revise for the test after half term. Every time you have a question, just pause the screen, have a go at it, and then I'll go through the solutions with you. That way you can make the most of this session. These are the three things you need to know about polygons. Polygons are two-dimensional shapes with straight sides that are closed. There are no gaps. The interior angles sum add up to the number of sides, n, minus 2 times 180. The exterior angles of any polygon always sum to 360 degrees. Regular polygons are polygons whose sides are the same length. It's worth knowing the names of these polygons. Here's an example question. Find the interior angles of a regular hexagon. A hexagon has 6 sides. So to find the sum of the interior angles, we calculate the number of sides, which is 6, minus 2, multiplied by 180. 6 minus 2 is 4. 4 times 180 is 720 degrees. The interior angles sum to 720. However, we want to find the size of one of those angles. Well, since there are 6 angles in the hexagon, all we need to do is divide 720 by 6. We know that each of the angles is going to be the same because it's a regular hexagon. So that gives us each angle measuring 120 degrees. Here's another one for you to try. Pause the video and then I'll go over it. In this one, we're told that the interior angle of a regular polygon is 156 degrees. Now, think about the polygon. The interior and exterior angles of any polygon add up to 180. Suppose this is our polygon and the interior angle is 156 degrees. The exterior angle, therefore, is what's remaining of 180 degrees. So, to calculate our exterior angle, we calculate 180 degrees minus 156 degrees, which gives us 24 degrees. Now we know the size of our exterior angle, we can work out how many sides the polygon has. Since the external angles of a polygon sum to 360, and it's a regular polygon, which means all the angles are the same, to work out how many exterior angles, and therefore how many sides there are, we need to divide 360 by 24. 360 divided by 24 is 15. Therefore, the polygon has 15 sides. And another one for you to try. Pause the video, have a go, and I'll go over it. Okay, so this time we've got a regular octagon. We're asked to find the size of each interior angle. Well, I can find the sum of the angles in an octagon using the formula. n minus 2 times 180. n is the number of sides. In this case, there are 8 sides. 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 is 1080 degrees. Okay, so that's the sum of the interior angles. How are we going to work out what one interior angle is? Well, there are 8 interior angles, so all we've got to do is divide 1080 by 8, giving us 135. The interior angle of a regular octagon is 135 degrees. Let's try the second part. This time we're told the exterior angle of the regular polygon is 30 degrees. Okay, well, the sum of the exterior angles of any polygon is always 360 degrees. If it's a regular polygon, each angle's the same. So, to work out how many 30-degree angles there are, we've got to divide 360 by 30. 360 divided by 30 is 12. Therefore, the polygon has 12 sides. And the next one, pause the video here. Okay, this time we've got a 10-sided polygon. Well, let's use the formula n minus 2 times 180 to work out the sum of the angles in the 10-sided polygon. N is the number of sides, so we've got 10 minus 2 times 180. 10 minus 2 is, of course, 8. 8 times 180 is 1,440. We're not quite there yet because it wants us to work out the angle marked x, which is one of the angles. Well, if all the angles sum to 1,440, and there are 10 of them, all we've got to do is divide by 10, giving us 144 degrees. Okay, here's a tricky one. Pause the video and have a go. Right, well, this polygon has 6 sides here. So, to work out the size of one of the angles, one of the internal angles in a polygon, I've got to calculate 6 minus 2 times 180, which gives me 4 lots of 180, which is 720 degrees. Now that's the sum of all the interior angles. I only want one of them. There are 6 sides, so I'm going to divide 720 by 6, giving me 120 degrees. Okay, now I'm going to have a go at working out this angle. Well, this time I've got an octagon. Let's work out the sum of the internal angles of an octagon. 8 minus 2 times 180 gives me 6 lots of 180. 6 lots of 180 are 1,080. Again, that's the sum of all the internal angles. I've got to work out what one of them is. 1,080 divided by 8 is 135. So this angle here is 135 degrees. Now, as we know, angles round a point always sum to 360 degrees. So our final step is to work out the angle x. 120 plus 135 is 255 degrees. To work out the angle x, subtract from 360 255 degrees, giving me 105 degrees. The next topic we looked at was the laws of indices. If the bases were the same, and our base, remember, is A, we could simplify using 3 laws. I'm going to give you an example of this first law. If I had 2 to the power 5 times 2 to the power 8, I could simplify that by simply adding my powers 5 and 8 to give me 2 to the power 13. So if we multiply together 2 values where the base is the same, we can add together the power. Okay, next law. This time, if we're dividing 2 values with the same base, again, here's our base, and I've written it both as a fraction and as a division, because you might see it either way, you subtract the powers. So, for example, if I had 3 to the power 5 divided by 3 to the power 2, I'd have 3 to the power of 5 minus 2, which is 3 to the power 3. Here's the final law. If I've got a number raised to a power, which is then further raised to another power, I can multiply together my powers. Let's look at an example again. If I had 3 to the power 5, which is then squared, I can simplify that by multiplying together the 5 and the 2, giving me 10, so it simplifies to 3 to the power 10. Here's some for you to have a go at simplifying. Pause the video, have a go, and I'll go over the answers. Right, if you've had a go, you'll notice A, the base is the same. When we're multiplying, we simply add the powers. 3 plus 5 is 8, so it simplifies to 3 to the power 8. Part B, again, the base is the same. When we're dividing, we subtract powers. 8 minus 4 is 4, 3 to the power 4. And finally, if we're raising a number to a power which is all raised to another power, we multiply. So 3 to the power 5 all raised to the power 7 is equal to 3 to the power of 5 times 7, 35. Okay, there's a couple of special cases we have to remember. Have a go and I'll show you the solutions. I hope you remember that any number raised to the power 0 is always equal to 1. Therefore, 4 to the power 0 is 1. Part B. Any number raised to the power 1 is always itself. Therefore, 8 to the power 1 is just 8. Part C. We can simplify. The base is the same, both bases are 9. We're dividing, so we subtract the powers. 12 minus 10 is 2. So this simplifies to 9 to the power 2, or 9 squared, which we know is 9 times 9, giving us 81. If we're asked to work out the value, we're actually being asked to calculate. Okay, have a go at simplifying these, then I'll go over them. Number 1, we're multiplying, the base is the same, so we can simply add the powers, giving us m to the power 9. Part B, the base is the same again. We're dividing, so we can subtract the powers. 8 minus 2 is 6, p to the power 6. Finally, we're raising a power to a power. Be careful, because the 2 is raised to the power 4 as well. Remember, 2 to the power 4 is 2 times 2 times 2 times 2, which is 16. Our n is raised to the power 3 and then to the power 4. 3 times 4 is 12. Okay, here's another one for you to have a go at. Right, so again, the base is the same, so we can simply add the powers. 6 plus 7 is 13. Anything to the power 0 is always 1, even if it's an unknown. Slightly trickier, but just follow the same rules. Okay, the base is the same again. We're dividing, so we subtract the powers. 5 minus 3 is 2. On this next one, don't be afraid because there's lots of bits to it. Look at them in isolation. Start with the numerical term. We've only got 5, so we can only end up with 5. Then let's look at our x terms. We've got x to the power 4 and x squared. Okay, they're multiplying, so we add the powers, giving us x to the power 6. Finally, let's look at our y term. We've got y cubed times y. Now if there's no power, we know that means y to the power 1. So adding the powers, 3 plus 1 is 4, we've got y to the power 4. The next topic to revise is solving equations. Remember, when solving equations you must always do the same to both sides of the equation. That way it stays balanced. If you follow this system, it will help you to solve the equations. Step 1. Expand any brackets by multiplying out. If there aren't any brackets, you can go straight to step 2. Collect the unknowns onto one side of the equation. Finally, step 3. Solve the equation by carrying out inverse operations in reverse order. Let's look at this first example. There aren't any brackets, so we don't need to expand the brackets. There are, however, the unknown on both sides of the equation. Choosing the smallest number of your unknown, in this case 2x, we're going to subtract 2x from both sides, leaving us with 7 equals 3x minus 11. Now I'm going to add 11 to both sides of my equation, giving me 18 equals 3x. The final step, divide both of the sides of the equation by 3, giving me 6 equals x. This is the same as x equals 6. It's always good to check your answer's correct. If we think about substituting x equals 6 back into our original equation, 2 lots of 6 plus 7 should equal 5 lots of 6 minus 11. 2 lots of 6 are 12, plus 7 should be equal to 5 lots of 6, which is 30, minus 11. 12 plus 7 is 19, 30 minus 11 is 19. Okay, our solution was correct. Let's look at this example. On one side of the equation, we have 3x plus 5 divided by 7, and on the other, we have 8. First thing to do is to multiply both sides of the equation by 7, giving us 3x plus 5 equals 56. Now, subtract 5 from both sides of the equation. 3x equals 51. And the final step, divide both sides by 3, giving us x equals 17. Okay, let's check it. We found x was equal to 17. Well, 3 lots of 17, add 5, divided by 7 should be equal to 8 if we are correct. 3 lots of 17 is 51. 51 add 5 divided by 7 is equal to 56 divided by 7, which is indeed equal to 8. Here's one that looks slightly different. We've got a negative number of x's. Now, do you remember the thing I said to do? If you ever have a negative number of x's, add that number of x's to both sides of the equation. So we're going to add 2x to both sides of the equation, giving us 10 equals 5x. Now it's easy to solve. Divide both sides by 5, giving us 2 is equal to x, or if you prefer, x equals 2. Let's check it. If x is equal to 2, 10 minus 2 lots of 2 should be equal to 3 lots of 2. Well, 2 lots of 2 is 4, so 10 minus 4 should be equal to 6. 6 is equal to 6, so we're correct. Okay, here's one with brackets. Remember, I said to expand the brackets first if you ever have brackets in an equation. To expand the brackets, we've got to multiply the 4 by everything inside the brackets. 4 times 2x is 8x. 4 times minus 7 is minus 28. So 8x minus 28 equals 10x plus 5. Now we carry on as normal. We're going to subtract 8x from both sides of the equation, giving us minus 28 equals 2x plus 5. Next, subtract 5 from both sides of the equation, giving us minus 33 is 2x. Finally, divide both sides of the equation by 2, giving us minus 16.5 equals x. It's perfectly all right to have a fractional or a negative value as your solution. Don't be afraid. Okay, let's check the solution by substituting in minus 16.5. I'm using the decimal form for ease. Now, remembering your order of operations, very important when you're calculating like this. I'm going to multiply minus 16.5 by 2, first of all, which gives me minus 33. On this side, I'm going to multiply it by 10, which gives me minus 165 plus 5. Then I'm going to complete the calculation in the brackets. And I'm going to calculate minus 165, add 5, which is minus 160. Finally, multiplying 4 by minus 40 gives me minus 160. So my solution is correct. Okay, another one with fractions. Let's start by subtracting 5 from both sides of the equation, giving me 2x over 7 equals minus 18. Now, let's multiply both sides of the equation by 7, giving me 2x equals 126, minus 126, because I've multiplied minus 18 by 7. Divide 3 by 2, giving me minus 63. Okay, let's check it. Substituting in minus 63, I'm going to make my life easy by dividing 3 by the 7 first, giving me minus 9. So I've got 2 lots of minus 9 plus 5 should equal minus 13. Well, 2 lots of minus 9 is minus 18, plus 5 does indeed equal minus 13. We've got it right. Okay, now your turn. Pause the video, have a go at these questions, and go through the answers with me. Okay, question 1. Let's divide both sides of the equation by 2, giving us y equals 4. Quick check. 2 times 4 equals 8. Yes, that's correct. Part B. Add 4 to both sides of the equation, giving me t equals 11. Quick check. 11 minus 4 is indeed equal to 7. Finally, part C. Multiply both sides of the equation by 4, giving me x equals 12. Quick check. 12 divided by 4 equals 3. Those ones are easy. Try the next ones. Here's another one. Pause the video, have a go, and then press play, and I'll go through it. Okay, start by subtracting 11x from both sides of the equation, giving us 2x plus 1 equals 9. Then subtract 1 from both sides of the equation, giving us 2x equals 8. Now divide both sides by 2, giving us x equals 4. Now the second one. Start by subtracting 3t from both sides of the equation, giving us 2t minus 4 equals 6. Now add 4 to both sides of the equation, giving us 2t equals 10. Finally, divide both sides of the equation by 2, giving us t equals 5. Okay, here's a load of equations involving fractions. Have a go at them. Pause the video. The answers will appear in a minute. Have a go at this one. Remember, if we've got a negative number of x's, add them first. Okay, here's how to solve it. Start by adding 2x to both sides, giving us 10 equals 18 plus 4x. Now subtract 18 from both sides, minus 8 equals 4x. Finally, divide 3 by 4. X equals minus 2. Don't forget to check yourself by substituting minus 2 into the equation. Here's another one. Pause the video, have a go, and then watch the solution. Okay, start by adding 3x to both sides, giving us 15 equals 60 plus 3x. Now subtract 60 from both sides, giving us minus 45 equals 3x. Finally, divide both sides by 3, giving us minus 15 equals x, or if you prefer, x equals minus 15. Don't forget to check your answer using substitution. You've also learned about inequalities. Remember, inequality means not equal. This expression tells us that x is larger than minus 4 and less than or equal to 3. If we were asked for the integer values which satisfy the inequality, we're asked to list all the whole numbers. X cannot be minus 4 because it's strictly greater than. It could, however, be minus 3, minus 2, minus 1, 0, 1, 2, or 3, because this is a less than or equal to sign. We can represent this inequality on a number line. The easiest way to do this is draw a number line, mark on the key points minus 4 and 3, and if you want to, you can fill in the points in between. Then we're going to indicate which values x could be. It can't be minus 4, but it can be anything larger than minus 4. So we put an open circle at minus 4. X can be anything all the way up to 3. It could be 3, so we put a closed circle by filling it in. We solve inequalities in exactly the same way as we solve equations, with one small exception. Let's have a look at this one. If we think about solving it like we solved an equation, we can start by subtracting 2x from both sides. If we subtract 2x from both sides of the equation, it gives us minus 4 is less than or equal to 3x plus 5. Now subtract 5 from both sides, giving us minus line is less than or equal to 3x, before finally dividing through by 3, giving us x is greater than or equal to minus 3. Remember I mentioned there's one difference between solving equations and solving inequalities. This is that if you multiply or divide both sides of an inequality by a negative number, you must reverse the direction of the inequality. So, for example, if I was solving the inequality minus 2x is less than or equal to 10, I could divide both sides by minus 2. This would give me x and minus 5. But because I've divided both sides by a negative, I must change the direction of the inequality. It's not often you'll actually have to multiply or divide both sides of an inequality by a negative number, and it can be avoided. In fact, you can avoid ever multiplying or dividing by a negative number by simply using the trick we use for solving equations. If you have a negative number of x's, add them to both sides of the equation, giving us 0 on this side is less than or equal to 10 plus 2x. Now subtract 10. 10 is less than or equal to 2x, and divide by 2, giving us x is greater than or equal to minus 5. After all, the two statements x is greater than or equal to minus 5 or x is greater than or equal to minus 5 written this way are identical. Have a go at solving each of these inequalities. Represent the solutions on a number line. Pause the video and the answers will appear when you replay it. Here are the solutions. The last section we did that'll be tested is on averages, range and interquartile range. For this section, I'd like you to make your own revision notes. Make sure when you do, you include how to find the mode, the median, the mean, the range, the interquartile range, and make sure you give the advantages and disadvantages of each one. Then have a go at some problem-solving questions.